Hello everyone. So this is one of those integration by parts questions that does look really horrible at first, but the right idea becomes much shorter than you might expect. Pause the video here and see if you can make any progress first, and I'm going to show you how the known results for the integration of e to the x sine x and the integration of e to the x cos x can be used to simplify the whole problem here. And I will quote these results here to keep the video focused on this challenge problem. But if you want to see the proof, I will link the proof video in the description. And right at the end, I'll show you something interesting, that two different looking answers that I got for this integral, both of which are correct. Okay. So, let me just write that integral. Okay, so that's what we've got to work out. We'll do that below. The two useful results that I want, I'll call them A and B. So I've derived these in a separate video. So A is the integral of e to the x sine x, which gives you e to the x over 2 sine x minus cos x. Okay, I'm not going to write the plus c's. And the integral of e to the x cos x, which is very similar. So these two will be used to simplify a lot of the integration today. Okay, so there's A and B. What you should notice is if you do A take away B, that will leave you with minus e to the x cos x, which is a useful result I'll use later. Okay, so back to the main integral. Here I'm going to set u to be x squared, which would mean u dash will be 2x, and v dash would be the rest, so that's e to the x sine x. Therefore v would be the integral of e to the x sine x, which we have as a. Okay, so I can just quote the result for that. Cool. So then if I plug all this in, that's going to give me that the integral of x squared e to the x sine x will be equal to, so we've got uv first, which will be x squared times by what we have here for v, so there's uv. Then we've got minus the integration of v u dash. So what you will notice is that v has a divide by 2 and u dash has the 2 there, so they will cancel, which will just leave you with x e to the x sine x minus cos x dx. Okay. So you can see I need to use by parts again on this bit here. So let me just write that out. So we'll have u as x here, meaning u dash is 1. V dash will be the rest. Just giving myself a bit more room. So that's v dash. So v would be the integration of that. Okay, so it looks like it's getting harder, but I have a little trick here for this part. We go back to A and B up here. You should notice A's got the sine x and B's got the cos x, okay? And this, if we do a bit of work on it for V, you'll notice something interesting about this. So I could split this integral up into two, which would be e to the x sine x dx. And then, because of this minus sign there, I can split that up. Okay. And if you think e to the x sine x is a and e to the x cos x is b, so I could write this as a minus b, and using the result up here, that is minus e to the x cos x. Okay, so that's the result I can write in for v. So let me just remove all that, and I'll just write in that simplified version. Okay, then all I've got to do is plug this in. So if I continue with this, I'm just going to write an equal sign, and I'll start here. We've got x squared e to the x over 2 sine x minus cos x. Then we've got subtract, and then the integrals here. So this is where I need to now sub in. I'm just going to put this down here. It might give me a bit more room. Okay, so firstly I need u and v. So that's going to be x times by minus e to the x cos x. And then we have take away the integral of vu dash. Noticing u dash here is actually just 1, so we only need to put v in. Okay, and if we just simplify what we have here, I'm still going to write everything. So nothing to be done to that front bit. But here we've got two minus signs acting on that, so that bit's going to go to positive. X e to the x cos x. And then noticing that we have two minus signs here, which will bring it positive, but then overall we have this negative sign acting outside. So this will be minus the integral of e to the x cos x. And we also have this result from earlier, which is there. Okay, so we can just substitute in the version for that. Just remember it's got a plus instead here. So let me just write that in. And then at this stage I can add the plus c on the end, since I finished integrating, and I can just do a bit of factorising. So I'm going to take out e to the x over 2, which will leave us with x squared sine x minus cos x. And then here, because we've took out the divide by 2, this is going to be multiplied by 2, so that's 2x cos x. And then again, we've took out the e to the x over 2, so we've got minus sine x plus cos x here, plus c. And that will be the final answer for this question. Okay, so there is a slightly different result that I did obtain from doing it a different way. So don't be put off if you do get a slightly different answer, because there is other answers which are equivalent to this one written in slightly different forms. So don't be put off if you do get one of those. I will write that result in here. If anyone wants me to go through that result, I'll be more than happy to. However, it does include more algebra. So this is the second result that you could get, which is nicer, and it does look in a better form. Okay. So both of these are the same. You can see the bottom one just looks a bit nicer. So have a go and let me know how you get on and what you get. If you found this helpful, then please do like and subscribe. I'll be more than happy to do some more of these hard integral content videos. Please do make a suggestion in the comments if you would like to see anything in particular. I hope this helped. Thank you very much and have a nice day.